so let's continue with our, so in lists we have these items, right? So we'll look at each item, like last time, sometimes we look at marks for instance, right? But the item itself might be something complicated, right? It could be like, for instance, if I look at a sentence, so it is a sequence of words, right? So at one level, of course, a word is an object, but sometimes we want to know how many letters on the word.
In fact, actually we did that. Some of our things we actually
counted the length of the word.
Of course, that is written, letter count is
Yeah.
there. But we did things with the word.
Yeah, correct.
Right? We went through the letters of the word.
Yes.
But kind of informally.
So maybe it's useful to think of the word itself again as a sequence of letters, right? So it's also a list.
So like it is a sequence of I and T, 2 letters.
Yeah. So I would say that the basic unit is one letter, A, B, C, D, any of the letters of the alphabet. Capital, small, we can distinguish maybe if we want. And then, yeah, we put these in a sequence and form a word. So every word is a list.
So we turn the word into a list.
Yeah, or we think of the word into a list. So we have to actually make, if we want to work with it as a list, we have a way to take the word into a list, right? So we want to take a...
Blow up the word into a list.
Yeah,
explode.
Let's call it explode.
Explode.
Explode
Okay.
is good, right?
So explode it. Explode it. So explode the word it, and that will give you a list which is I and T.
Yeah, it will give me something like this.
And similarly, was would give you WAS, I guess,
correct.
presumably. So that what that allows you to do basically is to, instead of informally working through the letters of the list of the word, you know a more formal way, because we have this structure called a list, to go through the, so when we want to go through the letters of a word, what we are actually doing is exploding the word, making a list, and then using whatever operations we have learnt about lists to go through the list elements.
Correct.
Huh?
Exactly. So it's not something different, it's the same thing.
It's the same thing.
It's just that you have to prepare that information to be in the form of a list. So that you can then use the list.
List constructs.
Yeah.
So it could be just a iterator like for each.
Yeah.
Or it could be the first and rest or whatever it is that we discussed.
Yeah. So for instance, if you want to count how many vowels are there in every word, we could just do a run a for each through that word, and for every letter which is a vowel, you
increment a counter, keep a counter.
Yeah. So that will be a standard iterator. Through each word, you will do this iteration and count.
Yeah.
Right? How many vowels are there?
Or if you want to count, in fact, something slightly more complicated, you want to check whether how many times a vowel is followed by another vowel. Rarely you find that. Okay, it's not that easy to find it, but it comes, right? So like for example, in this it is not there, in this it's not there, in this it's not there, right? Here also it's not there. It will not come actually, quite rare, no? Some languages have quite a lot of vowels following vowels, but in English you don't find it.
Yeah, sometimes you find it in OU, like poor or
poor, like that. Huh? So in this case, you have not found any so far, none. Huh? Monday, here it is there, I and A, especially. So whenever you want, so suppose you want to find out whether how many cards are there where one vowel follows another vowel.
Then you would have to do.
You would explode specially.
And then do this first.
So it becomes SPECIA.
Correct. So
it becomes.
So let us just write it out. So specially.
So that becomes a list. Yeah. And now we have to do that what we discussed earlier.
Yeah.
Which is?
First and rest.
First and rest.
So we would first look at the first letter and the rest, and compare the S to the first of the rest, and of course S is not even a vowel, so it doesn't matter.
Yeah.
And then when we finally come to this point, right, so we would have reached a list which has only the last 5 letters. At this point now we will say that the first letter is a vowel, and the first
of the rest is
also a
vowel.
So we have found.
So you found what you need. Okay.
So within this list there is nothing new that we are doing. I mean, it's just the old ideas, but it's the point is that we want to first get to a list.
Correct.
So it's nice to think of these, what we thought of as individual units.
So list as a pattern. In some sense, we are seeing list and the operations on list as a pattern, and we are able to apply it. So whatever we are doing informally, we are able to see that that can be converted into this pattern and used, right? So likewise, I guess there are other places like in this one also. We did informally we went through, wanted to count how many items of a certain category are there, how many items have been bought, something.
Yeah,
Here
so
at least the letter count was given here, but here that number of items was not listed.
correct. So each shopping bill is a list of items bought, and along with the list of items bought, you also have a list of categories. And of course, it's in the same order. So the same category might repeat, right? So you could have vegetables, food at the beginning, and then you could have vegetables, food again, and vegetables, food again. But this is what we were saying earlier. It's not a set. Right? It's not that we are just saying how many categories are there, how many different categories are there, but the sequence of categories matches the sequence of items. So we have a kind of correspondence. But
again, this is a list. So you can turn these items which are there here into a list.
Yeah.
And then you can explore the list one after that. Of course,
Correct.
each item in the list itself is complicated, so you have to figure out how to store that. But in the event that you exploded it into a list, then you can basically go down the list in the same way that we did.
Correct. So how
Using
many
an
rows
iterator
are,
or
how many
with first
rows
and
are
rest
there
or
in
whatever.
this? Yeah, the number
Yeah.
of rows in
Number
this
of
part
rows
will be equal to the number of
items in the list.
Yeah.
So is this, I mean, we have the iterator for each, and then we discussed first and rest. And now we looked at some of these natural lists which coming out of the cards itself, like exploding the word and all that. Is there a case to be made for looking at not just the first item of the list, but also sometimes the last item of the list?
Yeah, for instance, now supposing you have, let's go back to the first time we looked at first and rest, when we were looking at the marks, and you have satisfied yourself that the list is actually in ascending order. Then if you want to quickly get the maximum marks, you just pick up the last
element.
right? So you don't have to
go
through the whole
correct,
list.
correct. That's true.
Yeah.
First one will be the minimum.
Yeah. And the last one should be the maximum.
Last one should be the
And
maximum.
then you don't want to have to go through the whole list just to pick up that last.
Pick up the last element.
Or for instance, you might want to know how far apart they are, right? What is the range of marks between the poorest student and the best student in a subject?
This is the length of the list.
No, the range of the
marks.
I want the difference
between the first and the
lowest
last.
marks
Minimum and maximum.
So again, you can get the first.
You can get the minimum. You can get the first.
Get the last.
Get the last.
And then subtract. Yeah. Correct.
So just like first and rest, presumably there is a case for
last and something. We have to call it something. The initial part of the list. Right. So it's a long word. Let's just call it init. Right. So we have this list. Right. So what we said earlier was that we would split it after the first element and call it first and last, first and rest. So the rest is a list, the first is a value. And now we are saying instead we will split it this way. We will look at last, the last element in our list. Again, like first it makes sense only if there is at least one element.
Correct.
And this part is from the first element up to the second last element.
It's a list, again, a list.
It's a list, and this is the initial part. So let's.
So init plus. So I mean, we had this notation saying init plus some element, right? Yeah. So init plus and then in bracket the last element.
Yeah.
Would be the list.
Will be the list, correct.
But we didn't have a notation for first plus something.
Yeah.
That we didn't do.
Correct.
We added an element at the end of the list.
Yes.
But if we had, then that would be first plus.
Correct. Right. So you can take a new element. So supposing you wanted to add a list to, supposing you have a list L, right? And if you want to add a new element at the beginning, what we would have normally written was X plus L. If you want to add it at the end, you would say L plus
X.
X.
So you can say L is equal to, can you write an equation like that? L is equal to first plus.
Yeah.
First.
Correct. So for instance, L is equal to, so now we have first of L, but first of L is an element, so I must think of it to plus.
Because a plus does works on list,
and then you have to plus it with
the rest of list.
Rest of L, which is
already a list. Or
alternatively, we can say that you start with the beginning, right, and then you plus the last of it.
Okay, nice.
So these are two ways to
unbundle, unbundle it.
Yeah, decompose, unpack,
Unpack.
whatever.
So basically taking the list and you are saying either you take out the first element and get the rest, or you take the last element and get the beginning, or you can do both also.
Yeah, like we were looking at the difference in the minimum and maximum marks, that you would need the first and the last. Of course, in that case, we are not really worried about the remaining elements, but in this, we stop with just that. But you could imagine that you could do that also.
So, I mean, a good example would be palindromes, right?
Yeah, correct. So we might ask whether in a word, so let's think of a word, madam.
Madam is a palindrome, yeah. Malayalam is a nice palindrome.
Right. So what is the feature? It reads the same, going backwards and forwards is the same word.
Yeah.
Right.
So let's unbundle it. When you break that,
so you break it up
into,
so we explode it and it becomes.
Okay.
Right. So now what do we want to do? We want to check whether it reads the same forwards as backwards. So it starts with some letter. If it reads the same backwards, it must end with, if it starts with the same letter coming backwards. So it must end with the same letter that it starts.
So I want to take out the first.
Yeah. So I want to check whether first of this thing, let us call it W, right, is equal to last of W.
Yeah.
So that means that is M equal to M.
And once you've done that, then you want to remove both.
You want to remove both. So you have to first.
So you have to change the list to.
Yeah. So you have to first do it in either order, I suppose. You have to first get the rest. And then from the rest, you want to knock off this last element. Right. So then you want to take the.
You're assuming, of course, that it has at least two letters.
Yeah, because it has at least two letters.
Two letters, yeah.
If it has only one letter, then it's a palindrome because it's only.
Correct. So you're checking whether the first is equal to the last, and then you're taking the rest of the init or init of the rest of the list.
Yeah. So if I take init of rest of L
and make that equal to L,
this will strip off the two endpoints. And I could do exactly the same thing by doing it in the other way. I could first take the initial part, that is drop the last guy, and then
take the rest.
Drop the first guy. Right. So this is one way to.
So what you're saying, you start with a list. Assume it's got two elements at least.
Yeah.
Check first and last whether they equal. If they are, strip both of them off.
And then continue to.
So the list becomes smaller by size 2. Again check whether it has at least two elements.
Exactly.
If it has two elements, then again do the same thing. Keep on doing this till you.
So if you have one element or less, then it's a
palindrome. So in this case, that's what will happen, right?
Yeah.
You got M equal to M. When you strip it, you will get.
Yeah. Second step, you'll be with ADA.
That will be a smaller list, ADA.
So now you'll again check the first and the last.
So A and A are the same.
Yeah. And then you'll come down to this. And now you will say it's only one element. So there's nothing to check. So it's stop. And so madam is indeed a palindrome.
Nice.
Yeah.
So we can do powerful things with, looks like with lists, right? I mean, you can do a simple iterator for each, or you can start unpacking the list like this. You can take out the first element and the rest, or you can take out the last element and init. Or if you want, you can take out both elements and reduce it.
Yeah.
So make the list smaller and smaller. Basically, the idea is to start with the list, take out elements from it.
Yeah.
You can't take out anything. You can't take out some element in the middle.
You cannot get the fourth element or the seventh element. Or
you can't do that. You have to take either the first element or the last element. The endpoints of the list you can take out.
Yeah.
Reduce the list to a smaller size, and then continue the process. And in the process, you can do some examination. Either you can see all the elements and do something with them, or as we saw, we can do one element with the next element, right? And then reduce the list, and that helps you to.
Yeah, and I think for this it's actually useful to think of a list actually as like a stack of cards, right? So either I can take the first thing off and I separate it out this way, or of course I can, turn it over and take the last thing off. But those are the only two cards which are actually
accessible. In
because I'm not allowed to go in the middle and pull out something from here because it will mess up everything. So I should really think of a list that way for many things. I mean, there may be other situations where you might want to think of looking inside, but for most things I think we can either just go through it blindly, in which case we are ignoring the sequence completely. We just want to examine every card, or when we want to look at relationships between cards, very often it's between this card and the last card, or this card and the next card, and that's very useful to have these special operations for that.